So if you recall, over chapter 1, we cover a lot of different topics throughout the chapter, and then just in not in great depth, but cover many different terms and relationships. And then as we go through the rest of this course, we'll take deeper dives into each of those topics. Like we'll have a chapter where we explore angles and relationships much more closely. So just a brief overview here. The first thing we want to be able to do is name things like points, lines, and planes, right? So in the picture to the right here, we have plane P. So you see that capital letter P. Hopefully you can see how it's different from all these other letters, A, B. Even though it's capital, the way it's written in a specific script tells us that it refers to the plane. The other way that we can name a plane is with 3 points, 3 non-collinear points in that plane. So if I were going to say it's plane ABC, I can't do that because A, B, and C all live on the same line, and I wouldn't be explaining really where this plane is. It's this whole area here. So I need to take 3 points that are not on the same line. So if I started with A and B, I could call it plane. I can take any 2 points I want, but then the third point has to be off of that line. So maybe we would call it A, B, and then D. Okay, we could call it DBC or CBD. Okay, any of those would be okay for naming the plane P in a different way. Name line M in a different way. Well, where's line M? It's right here. That is line M. Easiest way to name a line is with that's lowercase letter. Right, here's line L over here. We don't have a single letter to name this line that's running vertical. But the other way that I can name line M is with 2 points. So go ahead and answer this one in the Edpuzzle. What's another way to name line M? So hopefully you said line DB. That would be a correct way to name line M. Now we have ray CB, so we want to be careful about this. Notice the notation here. This is a ray. So ray CB starts here at C, okay, and then goes off infinitely, okay? So it goes through B, but then it also continues and goes through A. So what's another name that we could name, or another way we could name ray CB? Okay, so hopefully in the Edpuzzle here you said ray CA. We have to have that same endpoint of C, but if we tell the line to keep going to A, it's going to be the same ray that goes through CB. Okay, now we have ray AC. Let's name ray AC in a different way. What's another way to name ray AC? So this ray now has to start here and go off for infinity. What's another way to name that one? So we could call it ray AB. Right, we start at A and we go off infinitely through B. That would be another way to name that same ray. Name the intersection of plane P and line FG. Okay? So let's see, where plane P is this whole plane here, and FG is this line shooting up vertically. Where do they intersect? Right, they intersect at point E. Okay. So now we have the intersection of plane P and DB, line DB. So plane P and line DB, well, line DB lives in plane P. So it's anywhere on that line. We could just say line DB is that intersection, right? DB is completely contained in the plane P, so it intersects with that plane everywhere that it goes. Okay, are E and D collinear? So E is this point up here, D is here. The answer to this question, anytime you have 2 points, are they collinear? The answer to that question is always going to be the same. It's yes, right? Any 2 points can be collinear, even though the line's not drawn there. I can always connect any 2 points. Now, when I invite a third point to the party, that's where we might get a no situation. So we have to look at these 3 points. We have A. We can run from A to B, no problem. They're on the same line, but as soon as we bring F in, we are no longer collinear. Okay. So coplanar means that the 3 points all live in the same plane. So like these points up here, A, B, and F, A, E, and B. They're all in this plane up at the top. Okay, so let's look at, this one could be a little bit tricky to look at, A, C, and F. I'm going to try to show you the plane. If I kind of cut across here, here's A and C and F. And imagine if we kind of drew like a wall or a partition separating these planes, and it came across here like this. You see that, like a slice, like a wall going diagonally across the room. A, C, and F would all live in that same plane. So we can picture a plane that those 3 points would be in. Same thing here with G, H, and B. If I go from G to H, they're down here, and B is up here. Suppose I ran a plane diagonally down there, right? So kind of like this, going an angle, sort of like a ramp, right? That ramp there from one side of the room, from the floor up to the ceiling, would be would contain all 3 points G, H, and B. Okay. Now we're looking for an intersection. So this would be yes. Name the intersection of CG and GH. It's almost a giveaway just by looking at these letters here, but CG is here. Right, that point just keeps, that line keeps on going if we wanted it to. And here's GH. So where do they intersect? Let's answer that in the Edpuzzle. So hopefully we said that they intersect at point G. Like I said, it's kind of a giveaway. Both letters are in the names of the 2 line segments. Now we want to name the intersection of a plane and another plane. We have plane CGD, which is this bottom plane down here. It's plane CGD, it's the floor. And BFH, where's that? B to F to H, it's like this sidewall over here. Okay, so where do those 2 planes intersect? Okay, so hopefully you said they intersected at DH. And 2 planes are going to intersect at a line. So next one, we should be looking for a line for this as well. We have plane ABC, which is just this front face of the cube. Shade that in. That's plane ABC. Let's try not to lose sight of G back there so we can see in case we need him for something. And then BEF. Where's BEF? That's the sort of the top of this box. Okay, so where do those 2 planes intersect? Hopefully we said they intersect there at line AB. Okay, so once we got to the point where we were comfortable naming points, lines, and planes and picturing these different situations, now we move on to linear measurement. So I have a couple of segments up here and I have the rulers. I want to be able to look at how long these segments are. So we start with segment MN. How long is that? Well, we know we have 3 whole centimeters by the time we get here. So I want to focus on how many tick marks is each centimeter broken up into. And if you count, you'll see you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of those tick marks is a tenth. And it looks like, if we can zoom in pretty closely here, that point comes right there where I have 4 tick marks. So we would say this is 3.4 centimeters. Okay. Now when we're measuring in inches, this is going to be different. Look at how many tick marks we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each of those tick marks is a 16th. So here I have 1 whole inch. And then what do I have left? 1, 2, 3, 4. That's 4/16, or just simply 1/4 of an inch. So this would be 1 1/4 inches. Okay. How about the next one, number 3? Let's answer this in the Edpuzzle. If RS is 2 centimeters and ST is 2.5, what's the length of RT? Let's answer that in the Edpuzzle. Okay, so hopefully you just added those 2 together and said that that would be 4.5 centimeters. Okay, our next one we have here, we have the whole segment is 6 inches, and then we have a part of the segment is 2 3/4 inches. So how long should BC be? Okay, so hopefully we subtracted here. We took 6 inches minus 2 3/4 inches, and that should be 3 1/4 inches. Okay, so now we have, we'll finish with these two today, and we'll pick up with the distance and midpoint in our second part of the review. Find the value of x and rs, x and rs, so we're finding two things here. We see at least in our homework assignments as well. And we need to recall that s is between r and t. So we want to try to picture a situation where we have r, t, and then we know that s lives somewhere in there. And don't worry if it's not drawn perfectly to scale. All right, we just need to be able to picture that so we can set up an appropriate equation. So rs is 5x. I'll write that here. That's from here to here. st is 3x. And then they tell me the whole thing, RT, is 48. So remember what we're trying to do here. We want to find x, and we also want to find RS. I know what RS is. It's 5x. So I'm going to have to plug in after I figure out what x is. So the first thing I need is an equation. What would be an appropriate equation here? So hopefully you said 5x plus 3x equals that whole segment piece, 48. Okay? So this is going to be 8x equals 48, and then we just divide by 8. So we have x is 6. So if x is 6, now we can easily go back and get rs. And I haven't drawn this to scale. Look, 5x is bigger than 3x, but we've drawn it the opposite, but it's okay. So to find rs, we got x equals 6. So what would rs equal? So hopefully you took that 6 and just multiplied it by 5 and said that that would be 30. So our two answers, x and rs, 6 and 30. Okay. Let's look at the next one. And we'll finish with this one for today. Again, I want the same kind of picture here. I need to follow the directions that s is going to live between r and t. Not really concerned with whether I've drawn it to the right scale. I'll still be able to solve for x and solve for rs, right? We want x and we want rs, two things. And again, I know that rs is 2x. So once I have x, we'll be fine. So rs is 2x. That's right here. st is 5x plus 4. Okay. And then they tell me the whole segment, RT, is 32. It's kind of a sloppy T here. But the whole segment, RT, is 32. So what would be my equation to solve for x? Good, so hopefully we said 2x plus 5x plus 4 equals 32. And we solve for x. Tell me what you get when you solve for x here. So hopefully we said 7x plus 4 equals 32. Subtract 4 from both sides. So we have 7x is 28. So we should have came up with x is 4. So if x is 4, then we want to find, that's our first piece of the puzzle here. We know that x is 4. So if x is 4, what's rs? So hopefully you said rs would just be 2 times 4. We know x is 4 now, so that should be 8. That's our two answers.